Today we're going to be looking at solving and graphing nonlinear systems of equations. You need the paper that you picked up on the way into class, or you can copy the one from OneNote onto your own paper if you miss class. First, we're going to start out by matching these systems of equations with the correct graph, and then we'll identify the solutions and circle them on the graph. So, scrolling this up a little. It will be helpful to you if we label or number these because there's no way to indicate which ones are which. So I'm just going to number these 1, 2, 3, 4, 5, and 6. And then we'll label the graphs A, B, C, D, E, F. Okay, looking at the first set of systems, we see that we have a parabola that has not been transformed in any way. This parabola is the parent function. It's at the origin, and it has not been stretched, shifted left and right, reflected, none of those things. And then with that, we have a line. This is the line y equals x, but it's been moved up 2, so its y-intercept is 2. If we look at this first graph, we can see that we have a vertex here at 0, 0. The shape of the parabola is what it should be. And then we have a line with a slope of 1. And the y-intercept here is at +2. So this is our solution. Question 1 matches graph A. And it says to circle the solutions and then write those on the line as a coordinate pair. So the solution to the left looks like -1, 1. And the solution to the right is 2, 1, 2, 3, 4. Handwriting is not so good on this screen. So that's what you do with these two problems. With these problems, you match them. If you look at the graph B, you can see that you have two parabolas. They share a vertex. And so that means you're going to have either number 4, number 5, or number 6. Those are the three choices that have two quadratics in them. They each have one positive and one negative, so it could be either of those three. So our next job is either to complete the square and put it in vertex form, or look at the y-intercepts. If we look at the y-intercepts here and here, we see that we have y-intercepts at +1 and -1. So that these two y-intercepts at +1 and -1 make equation 5 the match to graph B. So equation 5 is going to match graph B. So you should go ahead and finish out this section and match the systems to the graphs. Now that you have finished matching the systems, the nonlinear systems to the graphs, you should observe what you did and what you learned in those graphs and complete these blanks on this paper. Moving on to the next page, now we're going to look at solving algebraically. Following these steps, we're going to pick one equation and get y alone, substitute into the other equation, simplify, use the quadratic formula to find x, plug the x values into one of the equation to get the y values, and then write your solutions as ordered pairs. So for this first one of the equations has y solved already, so we're going to substitute that 2x minus 4. We're going to substitute this in here in place of the y. So I've drawn that here already, so we'll insert that. Can I move this thing? That's centered. So 2x squared plus 4x is from the original. The minus sign and inside the parentheses is 2 times x minus 4, and all of that is equal to negative 3. At this point, you would simplify, distribute the negative, combine like terms, move the minus 3 to the other side so that it's set equal to 0, and then you would use the quadratic formula to solve. So following through on those instructions, we see that we've distributed the minus sign here and made that minus 2x. Minus a minus becomes plus 4. It's still equal to negative 3. Then we combine like terms. 2x squared stays the same. 4x minus 2x is 2x. And we add the 3 to this side to get plus 7. Now that you have it in this format, then you use the quadratic formula to solve for x, and then use both those solutions of x. Choose either of these two solutions, either of these two equations, and substitute in the x value and find the y value. So we're going to fill in the values for the quadratic equation and solve for x. So you can simplify the quadratic formula to get the x values of negative 1/2 plus or minus I times the square root of 52 over 4. But when you substitute that back in to get a y value, it's going to be a complex number. So just put no real solutions and then simplify your quadratic formula. Go ahead and finish the other 3 of these algebraically using substitution. So for this next group, we're going to add or subtract both equations to eliminate y. We will write the remaining equation in standard form, use the quadratic formula to solve for x, plug the x values into one of the equations to get the y values. Then write your solutions as ordered pairs. So we're going to, in this case, we're going to subtract. We're going to subtract this equation from this one. So we're going to be subtracting 2x and subtracting y and subtracting the 5. If we do the subtraction, we will get x squared. 3x minus 2x is plus x. Plus y minus y goes away, and 0 minus 5 is negative 5. So once we've added the two equations together, we get x squared plus x. The y's go away, and 0 minus 5 is negative 5. Then we move the 5 to the other side by adding it to put it in standard form. X squared plus x plus 5 equals 0. At this point, we use the quadratic formula, plug in the values, and find x. So this gives us negative b, which will be negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times 5, which is 20, all over 2 times 1. Again, we have a complex number, and you'll need to simplify this. It'll be the square root of negative 19, so you'll get negative 1/2 plus or minus the square root of 19 all over 2. Go ahead and complete this section on your paper using the steps for elimination.